warm-up today involves one of the concepts that we talked about for an inverse. And just the quick idea with the inverse was switch the x and the y, and then solve for y. That's how we'll get the inverse of the function. So, even though it's called f of x, remember f of x, that's the same as y. So my first step is just going to be switching the position of those two. So it'll say x equals the y right there. So switch the x and the y, and then solve. And our goal is to get the y by itself. So we have to do backwards of PEMDAS, which means we're going to add or subtract first. So this plus 2 is going to move over to the other side with subtraction. And then I have a fraction. You could times by 3 and divide by 4 and do that in a two-step process, or a faster way is just to times both sides by the reciprocal. And we're not going crazy here. You don't have to distribute that 3/4 over to the other side. So just leave that here, but notice a times by 4 divide by 4, a times by 3 divide by 3, that all reduces out. And I'm left with y squared equals 3/4 times x minus 2. And then my last step is to get rid of the squared value. So we're going to take the square root. Just remember when you do that, you do get two answers here. You get a plus and a minus. So I get a plus minus square root of 3/4 minus 2x, x minus 2, equals y. And then the only thing we need to do, just to make sure that we know that this is actually the inverse function, is we put that little negative 1 up. That's the symbol for inverse. Okay, so let's try that with the next one. Just a slightly different function, but it's the same process. We're going to switch the x and the y. Remember, g of x is the same as y. So when I switch that, we get 3 times the 5th root of y minus 7. And same steps, we have to divide by 3, or if you want, you could times both sides by the reciprocal. It doesn't matter if you put a divide by 3, perfect. If you put it times by 1/3, also perfect. And I'm going to do one step here that maybe you did, maybe you didn't. You don't technically need to, but remember that 5th root is the same as the 1/5 power. The reason why I do that is, for me, it's easier to think of how do I undo that. Now, keep in mind this y minus 7 is protected right now. It's protected because it's under the radical. So I'll need to undo that 5th root by raising it to the reciprocal power and raise both sides to the 5th power. You could write it as 5 or 5 over 1. And again, we're not going crazy here, so just leave the right side as 1/3 x to the 5th equals y minus 7. And then the last step, move that 7 over with addition. And there's my answer for y, which is inverse. We maybe should have called this g inverse, because technically that's what it was originally. It was the function of g. And then same thing here. This should have been called f inverse. All right, so then I threw an extension in there. And just to make this a little easier to see, I'm going to just grab what we know f
and g are. And let's just do a composition here quick. It says find f of g of 39. Well, let's start off with in a composition of a function, you got to do the inside function first. So I'm going to do, what is g of 39? Which means I'm just going to plug 39 right in there for x. So kind of use this as my workspace. The inner part is going to be 39 minus 7, which is 32. And the fifth root of 32, 2 times 2 times 2 times 2 times 2. 2 to the fifth power is 32. And then the fifth root and the fifth power we reduce out. So really, this is like 3 times 2, because the fifth root of 32 is 2. So that whole thing turns into 6. But notice, I didn't do anything with f. Right? F is the outside function. So now I have to apply f of 6, which is just telling me to take the equation f and let's plug 6 into it. There we go. So 4/3 x squared plus 2, but now we're plugging 6 in for x. And we can do as much as we need to in our head, or we can do it by saying, well, 6 squared is 36. And here's how I would do this, and it might be nice without a calculator. I've got 36 over 1 times 4 over 3. Well, wait a minute. What if I divide the top and bottom by 3? If I divide by 3, 36 divided by 3 is 12. And now I've got 4 times 12, which is 48, over 1 times 1, which is just 48. And then 48 plus 2 tells me that f of g of 39 is equal to 50. So we reviewed two things in this warm-up, inverses and the idea of composition of a function. We'll do more with that later on as well, in case you had some other questions. What I'd like to do now, though, is just do a quick recap of the Desmos activity we did the other day. And that was graphing square root and cube root functions. All right, so you were asked to... I just want to show you this. I think I might do this for the next couple weeks, so you always have this in your mind. So we did this yesterday, the Desmos, and then today we're reviewing for the test. Your homework, which some of you already finished because you did it on Monday, is just the Delta Math chapter review assignment. It looks really long, but it's just one problem from each topic. So it's faster than it looks. And then we have a little 30-point test on Friday. All right, so at the end of the Desmos activity, you guys were asked to write this down in your notes. I'm going to add one thing to it if you want to take that out from Monday. And your goal with the Desmos activity was to explore what does A, H, and K do to a graph. Now, you look at our general forms. The A value is what's called a vertical stretch. It's either going to make it stretch longer, which I like to think of it as increasing faster, or it's going to increase slower, which is a compression. It's going to kind of shrink it down. But the A also does something else when it's negative. If the A value is negative, it's going to take your graph and it's going to reflect it upside down over the Y or over the x-axis. And that's kind of one of the things, the big things that kids miss right here. Okay? Now, here's the part that you may not have noticed. And it's the h value. And I'd like you to add one extra thing to your notes. In an equation, when it's written, see how it says x minus h right here? X minus h? That's saying we're the opposite of whatever the equation says. So that's what I want you to just throw in right here. We'll say it's opposite of what the equation reads. So if you see an x plus 5 underneath the root, you're really thinking that's a minus 5. You're shifting to the left 5 units. And again, we'll go over this. But that's the one thing that I feel like students didn't get perfectly from the Desmos activity. And then the k value is friendly. The k value does exactly what you think it's supposed to do. If you have a plus value, or even a minus, if it's a plus outside of the root, that's going to shift everything up that many units. If it's a minus, it's just going to shift everything down. And that's going to be true, by the way, this a, h, and k is true for any function we study. Chapter 4 when it was quadratics. Chapter 5, we didn't really look at chapter 5 here, but when we're going to do chapter 6 here and chapter 8, the a, h, and k does the same thing. The only thing that changes is the shape of the graph. So it's kind of really nice for, if you guys can have this general idea of what these a, h, and k do, then all it is learning a new function and what it looks like. So our goal is to use this and just do some quick review. Now, I don't know if you want to write any of this next stuff down or just answer the question, but what I'd like you guys to do is take this general form, either the square root or the cube root. Notice they're exactly the same except for the index number. And I want you to try to write an equation for each one of these. So you don't have to draw the graph. But I'll give you maybe a minute to see if you can write the equation for both of these. So first thing is just to identify, is it a cube root or a square root? And the cube root is the one that looks like the long S. So I know that the function has to start with that parent function. Now, one of the things that's important to notice, and they don't have it here, but most of the times they will, is they usually indicate like that center point, which sometimes people think of that as a vertex because that's how we learned it in algebra with quadratics. Not technically the same as a vertex, but that's our key piece here. So now, what I want to do is I want to think, what happens if I move over 1 unit? Am I going up or am I going down to get to the next point? And since I'm going down, that's a reflection. It's going to make the graph, and another way to notice this is notice how the graph is decreasing from left to right. That means my a value is going to be negative for sure because there's a reflection. And then the a value is how far is the first dot away. So I went over 1, down 1, 2, 3. So this length here actually tells me the a value. That, I think, was not super clear in the Desmos activity. And that's the hardest thing to do, is just identify that a value. So, how do we find the h and the k? Well, the h is from the origin, how far did I move over to get to my center spot? Well, here I went 2 units to the right. So, h is equal to 2. And then the k value is how far up did I go from that, which happens to be 3 as well. Now, pure coincidence, I just want to make sure that this is noted. The a value and the k value are not always the same. All right? In terms of 3 and 3. That's just a pure coincidence that a is 3 and k is 3. Now, when I write this, this is the key piece here. Watch what happens to the h value. So we get a is -3. I have the cube root of x minus whatever h is. So when I plug it in, the equation reads opposite of what you think it would be. So see how it reads x minus 2? Well, that's a shift to the right 2 units. And then we put the plus k outside, and there's my equation. Now, the nice thing is the square root one is basically the exact same idea, except for I don't have a center spot. I really have a starting spot. So what I like to do is I like to think of the a value. If I went over 1, how far up is it? Or down, but in this case it's up, to get to that next spot. So 1 unit away tells me that a is a positive 2. And then I have x minus, well, for the h value, we always go from the origin. So where is the starting point? How did I get there? I went over -3 units. So notice when I plug that in, see how it's going to be a minus of a minus? That's going to turn into addition, which will read opposite of the way we think. And then the k value is the vertical shift down. So 1, 2, 3, 4, 5, 6. That's supposed to be a negative, doesn't look like it. And then if this was written more accurately, or correctly I should say, it would be x plus 3 minus 6. So if you can write the equation from a graph, I feel like you can answer almost any question we could throw at you. This is probably the hardest piece. Okay? And I think one of the most challenging things is identifying that a value. So let's try a couple other problems that are somewhat similar in nature. And I just want you to answer these. If my equation is y equals -2 square root of x minus 5, which option here best describes the transformation of the parent function? So what's the best description that fits for that equation? So if you were watching the video, I forgot to hit record. The answer is C, because the negative reflects it over the x-axis. The 2 is a vertical stretch. And the x minus 5 is opposite of what we think, so it moves 5 units to the right. All right. I'd like you guys to try this one. You don't have to write this down, but I just want you to write the equation from this description. Here's the way I would dissect this problem. So first of all, we know it's a cube root function. So in my brain, as soon as I see that word cube root, I'm thinking of the parent function, the general form. And then I'm going to say, all right, we have a vertical stretch of 5. Well, that vertical stretch is my a value. And then it's shifted 2 units to the right. So that's going to be my h. I'm shifted down 1 unit, that's my k. But then I have a reflection over the x-axis. And you see that reflection, that's the negative piece there. So when I read this, I'm thinking, there's my a, but it's going to be a -5 because of the reflection. So those two are kind of connected. And then I have x minus h. Now, I'm shifted 2 units to the right. So if I have 2 units to the right, that means h is +2, but when it gets plugged in here, it's going to read the opposite of what you think. And that's usually the error that I see the most. So be very careful on that. And then the last one, the shift down 1 unit. This is k, and the fact that it's down means we're going in the negative direction. All right. The nice thing is we have a couple of problems in the review that are similar to the ideas we just talked about here. So you get a chance to get some feedback. Delta Math doesn't have its own topic on this, so unfortunately you can't do more of these problems. You can only do the ones that I had written in there, and you either get it right or wrong. I'm not taking points off if you get it wrong. I'm just looking that you did that problem, so you don't have to worry about if you got it right or wrong. But it's just something to give you guys some feedback. Okay, what is on our test for, I shouldn't even really call it a test. I should call it a quest, because it's right in between a quiz and a test. But it's 30 points, it's Friday, and it's covering solving, which we're going to review again today. So solving anything with a root, cube root, remember it could be fifth root, or it could be written like the fractional exponents. When you solve, you do have to check for extraneous solutions. All right? Determining inverse functions, we already did that in the warm-up. Combining and composing, this is the composite functions that we also did in the warm-up. And then graphical analysis of radical functions, cube versus square roots. That's what we just talked about. So the nice thing is we already did a good amount of review today through the warm-up and then the last couple activities. What I'd like to do then is give you guys a little bit of an opportunity to practice a few problems that we haven't done in a while and just give some feedback. So can you see that okay in the back? Your eyes are better than mine. So what I'd like you to do here is remember, if I have 64 to the 5/6 power, all I want you to do is rewrite it in the alternate form. So this one is a fractional exponent. Can you write it so it has a root in it? And then for 7, it has a fifth root. Can you rewrite it so it has a fractional power? You don't have to solve it, just rewrite it. And then for the ones down here, this is the composition of a function. Try g of h of x and f of x. And we'll give you a couple minutes on each of these. Okay, so for the first two, we just have to rewrite in the alternate form. So here's the way I think of this. Think of this divide by 6 as the 6th root. And then the 5th power can be written inside, so this is one of your answers. Or, we haven't done a lot with this, you could also pull that 5th power on the outside. So either of those are perfectly acceptable. Alright? And then with this one, we've got negative 32 to the 4th power, and then the 5th root is just a divide by 5. And I would write that one as negative 32 to the 4/5 power. Notice how I put that negative 32 in parentheses? I think that's a good idea. Alright, so now we've got g of h of x. So what we need to do is figure out what is h of x. H of x is x divided by 4, which, by the way, if you want to rewrite that, some students like to think of it better as 1/4 x. Same thing. I don't care how you write it, but that's going to replace h of x. So now I have to do g of the new input, x divided by 4. So I'm going to go back to g, which is x to the 3rd, and then we're going to replace the new input with x to the 4th. Now you could leave it like this, or you can write it as x to the 3rd, or divided by 4 to the 3rd, which is really 4 to the 3rd power is 64. So if it was multiple choice, this is what your answer would look like, and you'd have to know how to get there. All right, I'll do 31 over on this side because it deals with f.
So, f of x. Well, I have to just replace the inner part with what is f of x equal to. That's negative x plus 4. So now it's telling me to use that exact same function, but with a new input. So I'm going to go back to the function of f, which is opposite of x plus 4. But now, instead of writing x, I'm going to replace it with x, negative x plus 4. Now, if this was multiple choice, they would simplify by distributing the negative to each one of those terms. And when I do that, a negative and a negative turn into a positive x. And then I get a minus 4 plus 4. And that minus 4 plus 4 are going to cancel out. So f of x is just equal to x. So in the warm-up, we saw how to do it if there was a number there. This is just doing the straight composition using the functions only. All right. I don't know if we need to do this one. Are you guys feeling okay on the inverse? Switch the x and the y? Okay. I don't think we need to do that. You get practice on delta math. What I really want to do is spend time on the solving, because we haven't done this in a while. I mean, in a week. So why don't we do this? Why don't you guys try to solve these two and check for extraneous solutions? I'll give you a couple. So solving, we're just undoing the equation to isolate the radical expression. So in this case, I have to isolate the x to the 2/3, which means that multiplied by 7 has to move over to the other side first. And then if we do 175 divided by 7, we get 25. Now we have to undo the power of 2/3. So I'm going to raise that to the reciprocal power. And just the goal here is eventually, if we had more time this year, we would say, you can do this without a calculator. And I'm just going to add one extra little step here. This is what my brain's thinking. See this divide by 2? That's the same as the square root. And then what if I push that power of 3 on the outside? Well, wait a minute. What's the square root of 25? That's 5. And 5 to the 3rd power is 125. So, eventually, in maybe next year, you'll get to there where you can do that without a calculator. But in this case, now let's check. Take 125 and plug it in for x. Remember, if you're doing this in your calculator, I would put parentheses around the 2/3 just to be safe. So I'm going to do 125 to the 2/3 power first. And that'll give me 25, and then times that by 7. And you can see that when you check, you get a true, accurate, real answer. Okay? All right, the next one. We have to isolate the cube root in this case. So I have to move the 6 over with subtraction. So I'll subtract 6 to both sides. Now I can't do anything with the 5 or the minus 1. That's protected because of the root, the cube root. So now I have to undo this, and we said you could totally skip this step, because if you realize that you're just going to cube both sides, you could do that now. But what we wanted to teach you at the time was to undo a cube root, you raise it to the 3rd power, but why? Because it's the reciprocal
of 1/3. So we added that extra little step in there to hopefully build some meaning. But then 4 to the 3rd power is 64. Right, yeah. And then we're going to add 1 and divide by 5. I should know that, but great, not working. 13. And again, we're not happy until we check, because if this was a multiple choice question, we could try to trick you. We might put an option out there that mathematically appears, but if you didn't check it, you might think that's an answer when it's extraneous. So you do have to check, and again, you can just check right in your calculator. But you're going to do 5 times 13 minus 1 plus 6, and then our goal is, does that equal 10? Remember where the cube root button is? It's on your math. So hit the math button on your calculator, and it's the 4th option down. So if I was doing this with my calculator, I would get 64, and then I'd have to do the cube root of 64, which is 4. And that proves that 13 is an accurate answer. All right, last problem of the day. Of course, we're saving the most fun for last. I'll scroll up in case anybody's still looking at that. But go ahead and give this one a shot. This is about as hard as it's going to get. So if you can do that, you're in a good spot. So we know this is the one that requires a lot of work. And there isn't anything we can do to isolate this plus 1. So what I would do first is just take and square both sides. And the nice thing is the square and square root on the right go away. Over on the left, that requires a little bit more work. I have to multiply all that together. And when I do that, the square roots are going to reduce out for the first box. And then I've got plus 1 square root of 3 minus x plus 1 square root of 3x minus 8 and plus 1. And when I add all that together, I know this is a lot faster than I probably should do it. We get the first box, and then the second 2 boxes are like terms, so I'm going to add those together to give me 2 square roots of 3x minus 8 plus 1. That's usually the step that the kids struggle with or is the hardest part. Now, everything else, except for this cube square root, is going to move over. So I'm going to do a couple steps in one here. I'm going to move the plus 1 and the minus 8 over to the other side. And I'm also going to move the 3x over to the other side. So 3x, 8, and plus 1 reduce out. And then I am left with negative 2x, and 5 minus 1 is 4. 4 plus 8 is 12. I did kind of a bunch of steps in one there. And then I have to divide every piece by 2. What we just did there is we created a brand new problem that has a radical in it. So, and we have to square that. We will finish this in the afternoon, just to give you guys some feedback. Those of you at home, I think we got you in a good spot. Remember, tonight's homework is Delta Math, so make sure you chip away at that. All right, and then test is in Schoology on Friday. Adios. Have a good day.